Good morning, students. Today we will see the first experiment in our electrical testing 5 lab electrical power system simulation laboratory. So the first experiment is introduction to Matlab and Simulink. So in this experiment we will see the basic commands in the Matlab and basic connection diagrams in Simulink, how to do using Simulink. So basically in Matlab we can do programming or we can do Simulink. So here in this experiment we will see these two, how to implement the simple commands and how to do the Simulink. Please open your lab manuals and see this page. So here we have command 1 plus 1 semicolon. So suppose after opening the Matlab, if you in this command window, if you type 1 plus 1 semicolon, so there is no output here. You will not get any output here. But for the same command, if I remove the semicolon and if I enter, I will get the result. So what you can understand here, that the semicolon is stopping the from displaying the result. So if you don't want to display results of any command in Matlab, after the command just put the semicolon. So if you remove the semicolon, you will get the output. Like this we can do simple mathematics using this Matlab. 3 multiplied by 2 is 6. Here for multiplication the star symbol is used, and for power, to the power, we will use this symbol, to the power 4. So this is to the power 4 is 16. So next command, 16.6 minus 3 divided by 6. So what is the result? See, here we got 16.1, means here it is doing 3 by 6. First it is doing the 3 by 6, means it is implementing the division and then subtraction. Otherwise the result will be different. Suppose if I use this command like 16.6 minus 3, suppose if I make like this and here by 6, so the result will be this one. So if you want to do particular mathematical calculations, please use brackets so that you can differentiate. Now go to the next command, sin 90. So sin 90. So generally we know that the value of sin 90 is 0.8940, but actually sin 90 value is 1, but here we got 0.8940. Why? We will see this. So first of all, clear the screen, CLC. So now see, sin 90 value, we know that it is 1, but it is giving 0.890. Now see, sin D90, how much it will give? It is giving 1, means actually sin 90 value is 1. We know that. Why? Because when it is considered as decrease, it will be 1. Suppose it is radians, the value will be 0.8940. So here the value which is given as 90, it is considering as radians. So take the second command, sin pi by 2. So pi by 2. So naturally pi will be in the radians, so it will give the value directly 1. So suppose if I take the value of sine 45, sine d 45. So what is the value of sine d 45? 0.707. Suppose if I round it, round sine d 45, now it will be 1, means it will round to the next digit. So like this we can practice some commands and clear the screen. So now next, go to the next one. Suppose if a is equals to 1, b is equals to 2 and c is equals to a plus b, so it will give the answer 3. Suppose in place of small letter c, if I replace with c is equals to a plus b, it will give error, means we have not defined the functions a, b and c. So it is asking whether c means is a plus b. So here you can observe that the Matlab is case sensitive. So if you give the uppercase letters, you have to mention all the uppercase letters, or if you to mention the lowercase letters, you have to mention the lowercase letters. So this is what we have seen now up to this. Now we will go to the Simulink. So how we can open the Simulink? Here just type Simulink, or you can open from here also. If you press this, you will be opening the Simulink. First open the blank model. See, this interface of this Matlab will change with the version. Don't confuse with the versions. You can use any version of the Matlab, but use latest version available. So this interface change with the Matlab. So don't confuse with this. So if we open this library browser, so like this, so you can see in the page number 6 this library. So like this, a library will be opened. Here you can search whatever the, see, like we have books library. So you will have a library of different things here, electrical engineering. Suppose if I want to make a circuit like this, which is shown in page number see this one, page number 11. So I want to make this diagram. Circuit diagram. Yes, I want to make this circuit diagram. So here what I need a sine wave, I want a integrator, and I want a scope, and I want this multiplexer. So what I will do from the library, I will search this. See, suppose if I type sine and if I press enter, so I will get this sine wave. So I can drag and drop here. And what I want else, sine wave integrator. So see, this is the integrator. So just right click and add to model. And what else we need? We need multiplexer. You can search with mux multiplexer, this one. Input two inputs and one output, and we want scope. This is my scope. Now just connect this. Easily you can connect. So go to the next page. So you will see the complete diagram here. See this one here. Okay. So now, first of all, after making any circuit diagram, please save it. So I am saving it as experiment 1. So here for saving, the rules are you should not start the file name with number. Remember that, and you should not use hyphen. You should not. You can use underscore but not hyphen. So PS experiment 1, and I am selecting this in the downloads folder. I am making a new folder, electric testing 5 lab. So in this folder I am saving this. So now if you go for the configuration page, in the configuration page we can configure different parameters of the circuit. So here this is the configuration page. So here this one you can see here in the simulation, you can see the configuration page. So here check the solver. So variable step. So here stop time is we are giving as 20. So this interface changes with the version you are using. Okay, don't confuse with it. So just run it. So if we run and double click this scope, so you will get the output like this. So this output you can see in the page, next page. So here you can, if you want, you can make changes to this by using these tools. So here I can title I can give here experiment 1. Y-axis label I can give here. I can give Y-axis as some voltage. See here, when I give the Y label here I get this voltage. So like this you can simulate any circuit diagram and you can see the results. Okay, thank you very much. There are remaining circuit diagrams in this experiment. Please practice those, and if you have any doubt, please let me know in simulation. Thank you very much.